Okay, so we're asked to consider the curve y equals a root x plus b over root x, where a and b are constants. So the normal to this curve at the point where x equals 4 is 4x plus y equals 22. Find the values of a and b. So what I'm going to do first is rewrite this in terms of, with y as a subject, because that's an easier way to imagine functions. So y equals negative 4x plus 22, where negative 4 is the gradient of the normal. So now we're going to start to differentiate y equals a root x plus b over root x with respect to y. So I'm going to rewrite y with powers of x instead of square roots, because it's easier to differentiate that way. So this is our result. And then when we differentiate, so dy over dx, that gives us half ax to the power of negative half minus half bx to the power of negative 3 over 2, which is equal to a over 2 root x minus b over 2, and then the cube of x. Okay, so now from here, we can substitute 4 in to get the gradient of the tangent to this curve, which becomes a over 2 root 4 minus b over 2 root 64, which is just equal to a over 4 minus b over 16. And when we make it into one fraction, we get 16a, well, we get, 16a minus 4b over 64, which is equal to 4a minus b over 16. Okay, from here, what we can do is actually construct our general equation for the normal to the curve. So the normal, so we've got here the gradient of the tangent, but the normal is basically perpendicular to the gradient of the tangent. So what we're going to do is make this a negative reciprocal. So that means just flipping the fraction around and then giving it the negative value, which will give us the normal gradient, which will give us negative 16 over 4a minus b. So that's our gradient. Now what we're going to do is construct our equation. So actually when x is equal to 4, the y value is 2a plus b over 2, which is just 4a plus b over 2. So keeping this in mind, we're going to use our gradient formula. So y minus 4a plus b over 2 divided by x minus and then 4 is equal to our gradient, which is negative 16 over 4a minus b. Okay, just making some space down here. So y minus 4a plus b over 2 is equal to negative 16 over 4a minus b x plus 64 over 4a minus b. And now if we bring everything to one side, we get y is equal to negative 16 over 4a minus b x plus 64 over 4a minus b plus 4a plus b over 2. And that simplifies down to y is equal to negative 16 over 4a minus b x plus, and then over here we can just multiply to make it one fraction by cross multiplying to get 128 plus 4a plus b 4a minus b all over 8a minus 2b. So we get negative 16 over 4a minus bx plus 128 over 16a squared minus b squared over 8a minus 2b. And now what we do from here is we equate by parts. So what that means is over here we know the gradient is negative 4. And this here is also the same gradient. So that means negative 4 must equal negative 16 over 4a minus b. And then on the other hand, we have our y-intercept of 22, and this is also the y-intercept. So this is going to equal each other. So 128 plus 16a squared minus b squared over 8a minus 2b is equal to 22. And what we have here is a pair of simultaneous equations. So let's solve. So that becomes negative 16a plus 4b is equal to negative 16, which becomes Now I'm going to divide everything by -4, just because I want this to look a bit cleaner. So we get 4a minus b is equal to 4. So that's one part of the equation we can use. Over here is a little bit more complicated. We get 128 plus 16a squared minus b squared is equal to then 22 times 8. 22 times 8 is equal to 176, and then we multiply by a minus 44b. So I just multiply by the denominator. So what we get is 128 plus 16a squared minus b squared is equal to I'm just going to subtract it, minus 176a plus 44b is equal to 0. Now what I want to do is write this function in terms of one of these values and then substitute it into the equation. So let's solve for b. So b is equal to 4a minus 4. Now let's drag that into that function. So I'm going to do it on the separate page here. So assuming b is 4a minus 4, we're going to substitute in here. We get 128 plus 16a squared minus 4a minus 4 squared minus 176a plus 44 b. So that's 4a minus 4, which is equal to 0. 128 plus 16a squared minus, and then 16a squared plus 16 minus 32a minus 176a plus 44 times 4 is 176. So 176a minus, and then 44 times 4 is 176. So 176, which is equal to 0. So if we get 128 plus 16a squared minus 16a squared minus 16 plus 32a minus 176a plus 176a minus 176 is equal to 0. Already you might be able to tell that a lot of parts are canceling out, so let's just do that. So that's canceled out and canceled out. So we're left with this. And when we collect it, we get, so let's do 128 minus 16 minus 176. So we get 32a minus 64 is equal to 0. So 32a is equal to 64. That means a is equal to 2. Yay, we got a whole number. Now let's do it for b. So thankfully, we don't have to go through all this again. We can just substitute it into this equation over here. So b is equal to 4 times 2 minus 4. Which is equal to 8 minus 4, which is equal to 4. Therefore, b is equal to 4, and a is equal to 2. And that's our final answer.